All right, good morning, good afternoon, everyone. My name is Denise Myrick. I'm a product manager for the spatial and graph team here at Oracle. Welcome to Craig Shallahammer from Visosity. He is a Oracle ACE director, and he'll be doing our session today. Before we get started with him, just want to go through a couple of slides. So if you've been here before, you know that we put all of our past recordings up on askcon.oracle.com. If you search for graph for DBAs, you should find all the recordings there. They're also up on YouTube in our YouTube channel. And I'll drop some links when I finish speaking. If you have any topics that you'd like us to discuss in the future, we would love to hear your suggestions. Just drop us an email or during today's session, feel free to send a chat to Melly and I, and we'll discuss that with you. If you have any technical questions or discussions you'd like to have, there are two channels that the product management team does review regularly. So if you go to our Ask stackoverflow.com and tag Oracle Graph, or go to forums.oracle.com and go to the Graph community, we will be able to follow those discussions there. And just a little plug for A&D OUC. So they have monthly online sessions on all kinds of topics, including graphs, spatial, AI, analytics, etc. So these are some of the sessions that are coming up. They'll have a session in 2 days on where Oracle 26 AI beats Python and data preparation. Our colleague Karen will be doing a session in September on AI Database 26 AI and Link Curious. And then there will be a teaser on Oracle AI Worlds in October. Just a reminder, if you have any questions, please use the Zoom Q&A box. We do have a few product managers on hand to review those sessions or those questions, and anything that we can't answer, we'll get over to Craig while he's talking. And just a reminder to save the date for our next session. So we'll be meeting again on September 22nd, and that topic will be learning about the new Graph Modeler, updated Graph Studio, and other new features for AI. And the session after that will be on knowledge graph and ontologies for trusted AI queries in your data. So Craig, over to you. Thank you very much.
All right, let me share my screen. Got a bunch of people. I'm super stoked. You never know what's going to happen to you.
Absolutely.
You do it. All right, let me do the share. All right, can you see my screen?
Yes, we can.
Okay, fantastic. Did I get that right? The Oracle Graph product team. I didn't know what to put.
Yep, that's perfect.
Okay, great. All right. So, hey, welcome everyone, and yeah, thanks to the Graph team for having me. It's quite an honor to talk with people that actually even know what graph is, seriously, and don't turn and run. And so I put together this presentation, kind of like an applied kind of case study, and kind of the backstory to it, and I'll get into more of that even later, was I have a really good friend of mine, professional colleague, and got to know him like over the years through user groups, and he's from Florida, and he works for, those gift cards you get that, when you go to convenience store, those kind of things. Well, I'll say a very significant portion, anytime that card is swiped somewhere or used, their Oracle Exadata system just gets a little hit kind of thing. And he talks about the incredible amount of fraud that occurs that costs him millions of dollars. And he won't tell me, is that an hour, a day, a month, or a year? I just know that it's a lot. And I'm like, really? And so he's told me some of these different schemes. And one in particular, he actually will publicly talk about. And this is the scheme that I'm going to be talking about. And so I thought the only way I could do this, it's not going to be using, row by row processing. It's not going to be using connect bys and stuff like that. I said, this is the graph thing. And so I wanted to try and do this with all Oracle AI tech instead of using a bunch of Python and stuff like that. And it worked. I'm serious. I was like, wow, but it took a while. So this is kind of a journey that I've been on. And I really can't wait to update like the back end code on it, which you're going to be, you can download everything I'm going to talk about, including I won't do like the live demo, um, or even the recorded one. You can watch that. The slides are gonna do justice for that. So, okay, so here, let me get started like this, and I'll introduce myself in a minute too. So let's say, just pretend you're like the VP of operations, okay? And you get an email like this, okay? It says, and, you're like, crap, man, we got another fraud thing. So the question here is, well, how did the system even detect that fraud and then send him an email? Okay, so that's one side of it. Like, how is he even able to get this email? Okay, we're going to dive into that. Okay, on the other side of the whole thing, let's say let's say you're that guy, that creepy guy with green beer, right? He wants to pretend, he's from Ireland. He's the leader of an organized fraud ring. Like, we're talking organized crime here, no matter how small or big. And we're going to call him Slick Eddie. So how was Slick Eddie able to commit fraud and actually make a little bit of money? So we're going to talk about that too. Okay. So you have to commit the fraud, and then the detection system perhaps detects the fraud, and then the operations guy gets the email. So how's all that work? Well, that's what we're going to be talking about. But when you look at this guy here, you realize he's probably not the real Slick Eddie. The real Slick Eddie is probably this gal right here. And I love this because first time I gave this talk, my friend lives around St. Petersburg. And I'm thinking that is perfect because I'm sure there's ladies just like that there. And that's like the real Slick Eddie. But I'm still going to say Slick Eddie, and you can pretend it's either one of those. So, how are both of these situations even possible? So we're gonna get into that, and then I'm gonna explain how this whole gift card authorization usage kind of works, which is really hard for me to understand because that's not my background. And I'll talk more about why it's so difficult, especially for Oracle background people. I find it's really difficult to even understand what's going on. In fact, when I've talked about this once before, and I could see all of a sudden I could see boom, 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 all the like, all the ahas when they understand how complicated this is. And that's one of the things I really want you to actually learn. So my background is I started using Oracle technology in 1989. I think I had a full head of hair then, all that, and I started as an application developer with Oracle, not a database developer. I worked in the services consulting team, and then I quickly moved into the performance tuning group and kind of a SWAT team, we called it. And I went all over the world, started doing a lot of teaching about how Oracle works and how to make it run fast and all that kind of stuff. And then I kind of moved into capacity planning, predictive analysis. I love the neural network stuff, but it just was not happening, back then. And then when machine learning started to kick in a while ago, I'm like, and so I wanted to basically, I left Oracle and I started a company called OraPub it was focused on Oracle performance tuning. We had a community, a membership program, and I did webinars like almost every week. It was good. But I wanted to do more AI machine learning stuff. And so Viscosity, who's the company I work with now, they acquired OraPub. And so now I have this super cool title, which is my best title ever, Applied AI Scientist. So I'm a co-founder of OraPub. My wife is the other founder of that company. So all I do is like AI stuff right now. Some of the stuff I can't even really talk about yet. And I'm loving it. One thing I can talk about, and this is amazing how good this is. This is an Oracle like database, system performance tuning, basically a chatbot. It's a RAG application. Okay. like everything I've ever done with Oracle, this thing knows about. Like my entire history, this thing knows about it. And it's now to the point where you can just give it an AWR report. If you don't know what that is, your DBAs people, those kind of people will actually know what it is. And it will actually lead you through the analysis. It'll ask you proactively questions about it. And he's got like a surfer persona. So, and you can actually turn that down a little bit. Um, if English, is not like your first language, it can be pretty intense sometimes. Anyways, there's the QR code. It should go to the website surfershane.ai. So, all right. So Viscosity is the company. I first met them and why I wanted to talk to them about like acquiring Orapub. First time I met them, they were actually successfully, this is mind blowing, successfully migrating people to Oracle's cloud when it was first like announced and kind of working. I'm like, wow, these guys are special. So I worked with them. They're just fantastic people. You'll see a lot of these guys at conferences now. We have 5 ACE directors. Oh, I'm an ACE, Oracle ACE director. Yeah, just like Oracle Ice Director. Um, 5 of them. Nobody in the world, I guess, has that. So they're pretty proud of that. So I am going to do a practical AI boot camp. If you're interested in something like that, you can see it. There's the QR code. It's coming up. It's coming up like in a month or so. So I do one of these like every 6 months now, and it changes every time. We're going to use Claude Code instead of Cursor AI this time for the coding. It's not a coding class, but this is a great way to start doing stuff. Okay, we're doing great on time here. So here's the plan. What is this scheme? How is it even possible that it works? How does the gift card system work? Because they got to have both of those. And then how can we detect the fraud? Which is so cool about this solution, there's like a bunch of different technologies. There's graph, there's like AI stuff, there's like just classic machine learning is in here. So I love it. It's like all these different technologies put together. And then I learned a bunch of stuff. When I started doing this, AI coding was just kind of getting going. And I was using, I started with Sonnet, and then I went to Opus like 4.5 or something, and then it actually worked. And I'll tell you some of that, which is I'm sure it'd be much easier to create this now than it was when I did it. And then you can download all this stuff and watch it and the code and everything. So okay, so here's the scheme. So Slick Eddie basically buys like $100 gift card and activates it. Okay. Then he or she, whoever creates 4 clones of the card. So you basically buy the card, it's activated, you clone it. You can do that. Okay. Even with these chips and everything, I guess it's possible to do this stuff. So now there's 5 cards because Slick Eddie hands 4 of the clones, to his buddies. So there's 5 of them. So the next day, let's say all 5 of them go to the same city. I guess that's important. Okay, but different ATFs. And exactly, no, it doesn't have to be exact, but just around the same time. Okay. And the idea is that they want the system to be really active. So they're super busy and things can kind of slow down a little bit. And that's important to them. They each attempt to make a really simple, very common withdrawal. They don't want to be like, they don't want to stand there like, give me 500 and it's $20 or what is it? No, 60 or 80. And if you think about it, if just 2 people of the 5 get a successful withdrawal, even if they're both $60, they're going to make $20. Okay. Believe it or not, this can actually work. And I really wish I could try this, but I don't think that would be a good thing for Craig. So, okay. So so that's the scheme. It's actually pretty simple. Okay. And I'll kind of review that again. So the reason, I'll say there's a lot of reasons, but from my perspective, I'm talking to my buddy, because by the way, a lot of the details of this they're not online. There's not stuff that's written about it much. And some of the stuff that's written is just wrong. It's like, I told my buddy, I said, hey, this is wrong. And he says, yeah, it's almost like somebody posted the wrong stuff. Yeah. He's like, you know, tight-lipped. So there's 3 different systems. They are disconnected. They only talk to each other through APIs. It's highly regulated. And so there's three core systems, and I was able to simplify them down to three tables with just a handful of columns. Now, in a real system, there's going to be more tables. There's going to be, potentially more columns, but they want it small and fast with like the minimal latency. So why latency? Because they're disconnected. Each of these three systems, which I'll tell you about in a second, they can be different vendors, different companies, different data centers, different database systems, different code bases for each of these systems. So they are disconnected. So if you understand how the cards are like used, the systems kind of make sense. So on the bottom right here, the card activation system. Okay, that's when you first get the card. The PAN, it's called, is the actual card number. That's highly protected. It does not get passed around, because if you have the card, you can do a lot of bad stuff, I guess. Okay. So you got the PAN, and then it's either activated or not. Really simple. That's all that system's going to do. Like when the card is created, I guess there's a row inserted in here. And then when you actually like pull it up from the counter, and then you buy it and it's activated, or you call and get it activated, boom, that changes. Okay. When you first put the money on there. Now, when the money goes in there, what's going to happen is you're going to have these other two systems are going to be used. You have the balance management system, which is anytime there's a change in the balance, it's going to be recorded here. And there's like one record per card in the balance system. So you have this thing called a serial number, which is not the card number. We'll talk more about that. You just have the current balance, when was it last changed, and when was it activated. Okay. Now you might say, oh, okay, well, I know a timestamp, so there's probably a timestamp here. I didn't put one in there, but if there was, you can say, well, we have a foreign key relationship. No, these systems are disconnected. You can infer a relationship, but it's not explicitly stated, and it's not implicit, which makes detecting fraud incredibly difficult. Okay. So, but every time the balance is changed or attempted to change, there's going to be a row inserted into this transaction management system. This is like the activity log, and I'm told that this is used to actually check like the balance of a bank, like your bank account. That needs to reconcile with this system right here. Okay, so you have a transaction ID, you have a token, and I'll talk more about this, the type of transaction, which is putting money on or off, the amount, the timestamp. Again, you could say, oh, we can just join on the timestamp. No, that will not work. Okay, because there's latency. There's always a little bit of latency. And whether it was approved, you can have an attempt of changing the balance, but it may be denied. Right? So we've all experienced that. It's not fun. Okay, so three completely different systems, companies, like I said before. What's interesting, if one of these systems for a particular vendor starts to slow down, like the latency gets too big, or like the approval's not happening, like my buddy's company, they can actually like switch to another vendor. They don't want to do that, like, because they're dependent upon these other systems. But if the SLA is getting close, they will get like charged significantly if they breach the SLA. So they like flip to another vendor to do whatever needs to be done, or they'll just skip some of the fraudulent check steps. They'll say, well, we're going to take our chances. We've done the math. We figure it's probably worth it to let it go, even though we really don't know if we should authorize this. It's crazy stuff like this. I've never encountered this. Okay, so why is this so complicated? I mean, if being an Oracle person, my background, I would say, okay, great. We have three tables. We'll just have, it's a relational system. We're going to have foreign keys. We don't have to deal with all this disconnected, complexity, legal stuff, the latency. We have, all the two-phase commit. They can even be different systems. They can still, we can create a view of all the systems. No, you can't do that. The reason is because it's to protect you, me, and from vendors or anybody else. And what does that mean? We got PCI, privacy laws, et cetera, et cetera. Okay. This also means to protect us, fraud is actually possible. if these weren't disconnected, it would be much more difficult to actually create, do the fraud. It also means because they're disconnected, fraud is really difficult. So it's like for us, fraud's possible, and it's also super hard to detect. I know it's like what but that's the kind of the reality of where we're at right now. Okay. So here's how this just a quick review. I gotta get moving here. First, you got to purchase the gift card or whatever, and then it's got to be activated, which can happen all sorts of different ways. But basically, you got to have a card. It's got to be activated. That's that activation system. Okay. For this particular fraud, they need to be able to go to an ATM and just use that card to get some cash out. Okay. Not all cards are like that. Okay, which means it wouldn't work with this type of fraud, that kind of thing. Okay. And all of this is that workflow is actually those three systems. That's all you actually need. It's super elegant how this works. Okay, but this is how Slick Eddie does it, right? Slick Eddie still has to purchase the card. It's got to be activated. Okay, and then Slick Eddie's going to make the clones. Got the 4 fraudster friends. So this is actually legally, this would be an organized fraud, ring, kind of organized crime is what this is called. You think, oh, we're just doing gift. No, this is organized crime. It's a pretty serious thing. So now we have there's the 4 buddies and the original car. So there's 5 cars at this point. The fourth thing they do, right? They go to the ATM the next morning and they just do a non unusual transaction. And boom, right? If only 2 of them, get authorized and the cash comes out, they make some money. And then they probably run like hell away from the ATM. I don't know what they do, Anyway, so let's a closer look at the structures, and that's going to lead us to more of the technical solution here using all the AI tech and stuff. So this table, activation, that's really the first thing, right? You got to have a card, and then it's actually going to be activated. So the PAN, this is the card number. I don't know. It must have account number, personal account number. I forget what that actually stands for, but they'll just say PAN. And I'm using some of the words that my buddy actually used. So it's like their industry kind of lingo. So I learned a lot about this. Okay, so this is important. This balance management system. I mean, most people, and me included, say, okay, this is a serial number, and that's actually based upon the PAN. So using a PAN, the serial number is derived. Okay, so the serial number is not the PAN. It's actually going to be something we can actually just call it serial like 005. Okay, now important to know, and this is cool, the serial number is derived based upon the account number, but you cannot derive the account number based upon the serial number. It's like a one-way encryption. You can't go back. And that's actually really important because that you will then, if you know the serial number, then you can derive the account number, and then all sorts of fraud can happen because of that. Okay. So the rest of this is pretty straightforward. The current balance, blah, blah, blah. So this is not a foreign key. Is there truly a distributed system? You cannot go back. If there is fraud and you think there's fraud, you can, if you're the balance management system and you say, hey, we think there's fraud here, like we have the current balance, when things kind of calm down, you say, oh, the current balance is a negative $100. That's bad, right? We shouldn't have a negative balance. You can then contact the activation system and the other systems, but it's very legal. It's not like, hey, Fred, hey, we got a problem here. It's like everything's legally. It's super, like, you don't want to have to do that. It's not a trivial thing. Okay. Okay. So then we just talked about the balance management system, but that is closely related to this transaction system. Anytime there's an attempted change to the card balance, whether it's approved or not, there will be a transaction logged here. Okay. And like I said before, this is how you reconcile with the bank account. So this is important. A couple of key things. This transaction ID, it's a transaction ID for the transaction table. It is not a foreign key associated with this balance. Now, the mind-blowing thing here is that there is no foreign key, implicit or explicit, between the balance management system and the transaction, which if you got an Oracle background, it's like having an order number and you have order lines, but there is no parent-child relationship. I mean, mentally, it's like, well, yeah, there is, but legally and structurally, there is not. So how do you know which order line is associated with each order? It's like, how does each of these transactions get associated with a particular, like, not even account, balance row with the serial number? You don't, unless you do some really freaking crazy, amazing stuff. And some of that amazing stuff is in this presentation, I think. But they have to figure, or they have to kind of guess or infer a lot of this if there's problems. So it's that disconnected. This token right here is not something, it's not a relational database thing. It is like a token for like an SSL token. It's like a security token. They can actually be reused. All right, so which means you can't use it for a key. So I'll tell you more about that later. It's not a key, it's a reusable token. Okay. Or somebody might get the same one generated. Transaction type, and there's two different types. It's kind of interesting. You can put money on, you can try and get money off. Money in, money out. They call it funds on or funds off. That's what you do. The amount, the timestamp. Remember, the timestamp here is not necessarily like the last change time right here, because these are disconnected systems. There's going to be latency. And then, of course, was it approved or declined? Really simple like that. So you can see how fast these can be because they're actually really simplistic at their core. So, but there's exadatas that are just multiple exadatas kind of thing. Data centers all over the place. Okay, so I don't have a lot of slides on the technology, but you're going to see how I'm going to tell you how they kind of work under the covers here. And how was the performance? And I did this in Oracle Cloud, or I did in OCI and all of that. Okay, so everything, I could do everything with Oracle 26 AI, and probably even before that. I don't know what the cutoff is, but I was able to do everything. There was no Python. Everything was done in PL SQL or SQL or Plus or SQL CL and with Oracle. The only non-Oracle tech was I use an LLM to actually generate that email. Okay, so basically, once you think you have a fraudulent situation detected, you have some information. We're going to give that to the LLM as part of a prompt to then create the email, which then gets sent. So then we got some cool AI right there. So that's pretty cool. And that's how it works. So let's just kind of quickly go through these. So 26 AI, you have vector type columns, okay, which is awesome. So a vector, right? It's just a series of numbers, and we're going to talk more about that specifically in this use case right here, which is pretty cool. It's just classic machine learning stuff. So columns, and then you have the indexing. Now, this is kind of like a shout out to whoever these index researchers are, because indexing vectors is not a trivial thing. In fact, some of the solutions I've seen just seem so stupid. It's basically, well, you just invalidate it and you re-add something or you rebuild the index. I'm like, what do you mean you rebuild the index? There's these crazy solutions because it's so complicated. And you can actually, some of these indexes are actually based on graph technology as well, which is pretty cool. But we're not going to get into that. I just want to, if you mentally think about this, if you think about a tree structure, well, with normal, keys, whatever the indexes columns are, you just say, okay, if it's greater than this, you go left or you go right. Well, how do you do greater or less than with a vector? It's an array of numbers. Like, oh, and when you think about that, like, okay, there's some serious computer science involved in that. Okay. And there is. I actually talked to one of the guys who actually helped choose which index structure for vectors Oracle was going to use. And I saw him at a conference. So I went up and I talked to him. And I said, how'd you guys how did you do this? He says, well, we didn't actually, invent it, but there was quite a variety of choices and it wasn't an easy choice. I'm like, so it's really interesting. Okay. So we got vectors, column types, and indexes. By the way, when people say Oracle is just like a vector database, it's really like demeaning, I think, to Oracle, because really a vector is just another type, like an integer or a varchar. To like say it's a vector database lowers Oracle down into all sorts of truly vector databases. And Oracle does a whole heck of a lot more. All right, so this in SQL similarity searches, you can do it, embeddings, right? You take some text or whatever, you convert it to an array of numbers, it's a vector, and it can do in SQL distance functions, okay, which is more and more common now with SQL, with other vendors too. But it having in SQL, right, like inline embeds and then the distance functions, because you have all of the benefits of SQL in Oracle. You got all the parallelization, right? You have all the set theory, relational stuff, all that. You're not just, you're not just brute force, doing rows, which I could have used for what I did because it's a demo. I could have brute forced it and it probably would have been faster, but it will not scale. So it's a super big deal to have any feature put into the SQL engine. You immediately get all the benefits of the Oracle ecosystem when you do that. It's incredibly cool. Okay, then we got property graphs. Now, the reason I did this whole thing was I wanted to come up with a really cool demonstration of using property graphs other than what I've seen and how people talk about it. I really want something that was like real difficult and it just was unusual. And so, and it actually worked. Now my background is not graph, right? So, but I kind of get it. And so
Hey,
the
Brad,
graph yeah.
I'm so sorry to interrupt you. There is a
Hmm?
question that I thought you might want to answer before you move on.
Oh, okay. Where can I see that? Let's see. Yeah, thanks for doing it because I'm just like doing my thing here. Is that in the chat?
It's under the Q&A. So if you go to more.
More Q&A. There we go. Okay, excellent. All right. So when there's the attempt to withdraw money, isn't there a check yes, there is. There is. And that's that balance system. That'll tell them real quick, and then you have that. Yeah. But if you think about it, I guess one way to kind of realize or kind of get this is that think about like data guard or you're replicating. Data has to move. There's got to be a communication from like one server to the next. Whenever you have that, there's like a little gap. However small, there's latency. And when you have latency between the systems, if one system slows down, right, they can, there's an opportunity of fraud there. Okay. And it's not just going to happen with one transaction. If the system slows down, like I said, they can actually skip some of the fraudulent check. They can do that. There's the opportunities. So, but if you actually like kind of just think about all the different situations that could cause this, you'll kind of stumble upon, oh, so there is an opportunity because these are disconnected, right? Like the balance system may not see. It's like when the balance wants to be changed, it's going to send a message like an API call to that transaction system. While that's happening, another balance request I'll say like a withdrawal can happen to the same card. Okay. Well, the card, that first request has not yet been like fulfilled. It's like in transit. And so the balance is still like looking good. Right. And you can say, well, why don't they just stop that? Well, if they stopped it, the stuff could back up fast, I'm told. And so they kind of let things flow like that. Otherwise, you can get really, really bad stuff can happen. So that's the best I know how to answer that question. No. And the more you think about it and the more you kind of release the relational database kind of thinking, it becomes like, oh yeah, there is opportunity here. So, all right. So that's the best I can answer. That's such a good question. Yeah. Okay. So property graphs. Okay. So that's key to this whole thing. So normally you don't see property graphs drawn like this, but this is like a property graph, a partial property graph. So this is a design decision. And this is where knowing how to use graph effectively and experience is going to pay off. Okay. So each of the nodes right here is I define to be a transaction. So when you say create property graph, okay, this transaction is the column in the table, the transaction system, right? This is the transaction number 10, 14, 15, 16, 17, all of that. Okay. Now, oh, and it is a property graph. So there's properties here. So there's like columns associated with the transaction and just what you would think, transaction ID, the type, amount. So there's properties, I think columns associated with this node, this graph node right here. Okay. Now we have to have relationships. And this is key to the design of the whole thing. And I'm sure there are many ways to like create a graph to solve this kind of problem. This is just one of the ways. So what I chose, the relationships of the graph, the edges here, is going to be the delta in the transaction time. Okay. And therefore you're going to always go to like, transactions will get larger and larger and larger right here. And so these are all connected. This 1014 is not only connected to 1015, but also 1016. See, there's a direct connect right here. And how long that edge is, that's the time, delta right there. And so the transaction, I'll say the fraudulent set of transactions in this demo turns out to be this 14 to 18 to 24, 28, 37. And so I only show you part of that. So the fraudulent transactions are 14, then there's a link all the way to 18. But we don't know that, right? I mean, like I told you that because I set up the demo for those transactions to be the fraudulent transactions. But you don't know that. So you're just kind of looking through these transactions with all these connections, trying to figure out, is there fraud involved here? And it's going to get weirder in just a couple of minutes. But that's how I define the property graph. So defining the property graph is incredibly quick. It's like create table with no data. It's just DDL. Boom, it's done. When you traverse the graph, that's when there's a lot of CPU and because this is built in to Oracle, you get all the benefits of like parallelization in memory, like and you're referencing tables. It's like the tables are in the database. I mean, it like again, it's like SQL, embedding SQL into or whatever the feature is, like a distance function in SQL. You inherit all the abilities of SQL in the database. The same thing with the graph. It's not like this separate thing. It's actually part of the database. It's super cool. So you define the graph and then you traverse the graph using PGQL, property graph query language. And that allows you to traverse the data structure that you created when you created the graph. And it all works. Everybody's happy. It just works. Okay, so that's kind of the different technologies. So, okay, so I'll just say the demo data was freaking really difficult to create. I tried to use prompts and like Claude, it couldn't do it. There's too many numbers. It was just wrong. It even checked the work and said, "Yeah, Craig, I messed up again." Kind of thing. So what I did is I created a set of fraudulent transactions right here. So this is like I define it. So we have the funds on of $100, okay, and then we have the 5 cards, right? Remember, 4 clones, 1 original, and they're all trying to do funds off. They're all trying to get cash out all around the same time. And so of course, the funds on was approved. They will always take your money, get your money. And now this is like that one. The first one was approved, which makes sense. The second one was approved. Uh-oh. Now we're over our $100 right away. And the system still, because it was kind of got caught, it was behind. Another one was actually approved. Okay. So the total stolen was 200, which was 60, 80, and another 60. The system finally caught up, and for whatever reason, it then declined the last 2. Okay, so this was my demo data. So this is a specific pattern, specific pattern of a fraudulent, well, let's say, activity. Okay, that's important. This pattern is important because we're going to create a vector on this pattern. Okay, I call it fingerprints. So I'm gonna talk more. That's probably the next slide. That's coming up. Okay. So then what I did is, and this is the serial number. So this is in the balance management system, right? This is the serial number. The activation amount was $100 and the final balance was 100 after minus 100 after all of this is done right here. Okay. So all the balance management system knows is this information here. It knows nothing about this because it's completely disconnected. Okay. The transaction management system knows this, but all it knows is that we've had some approvals and we've had some declines. It doesn't know why. It just knows that that's the situation. I know this is so weird for me, even talking about it now. It's just so unnatural. So the data set I created 103 transactions. I could have created thousands. It doesn't really make any difference because the type of fraud is going to be within like a couple minutes. So regardless of 5,000s or tens of thousands, just because we're using SQL, it's not really going to make up it's not going to change the demo. It's just going to be more of a hassle for me. Okay. To make it more difficult, there are a total of, there's 5 transactions. There are, I don't know if I did this. Yeah, there are cards with negative balances. I didn't set just one because that would be obviously that's the fraud that we're looking at. I set it so there's five sets of transactions that end up in a negative balance. So I made it really difficult. I tried to make this real because I just get tired of demos that are not interesting. So that alone makes this really difficult because there are other issues in the system. Okay, so this is hopefully some of you guys you get the aha moment. So what all you know is that on the balance management system, this serial number has a negative balance. Okay, and this is like the last time the balance was changed, and then when the card was activated. That's all you know. You have all these transactions in the transaction management system. Somewhere in there, you're supposed to figure out the series of transactions that resulted in this $100 negative amount. So that's all we have. A bunch of transactions and we have a negative balance. Somehow we're going to figure out the transactions that are associated with that. That's the challenge. It's a really good problem. Okay. Now, if you're thinking, well, that's not possible, you're right. It's like freaking it's like impossible unless you have graph and you got some creativity and use some machine learning stuff. So one of the things that helped me do this, and this was like my hunch when I started this whole path here, was that I wanted to use similarity searches. I think similarity searches, I use them. I've done like Saturday projects where I on my own, created like a cancer detection system using similarity searches, and it worked. I don't know why. It's got to be used in real life. I didn't publicly put it out there. I'd probably get sued or something. But similarity searches are so flexible in so many different ways you can use these. Okay, I see the question this time. Is the property graph for all transactions, for all cards? Yes, in my demo it is. Yeah, they're all there, and it should be, because that would be kind of not fair. Yeah, for all the cards, the amount of the connections would be. Yeah, it is. It's totally exponential. It's insane. So you're going to see how I dealt with that problem. Yeah. Oh, you got it. You got it. It's like, whoom. Yeah. Okay. So what I did is I took that fraudulent scheme, those 5 transactions there, and I created a vector on this. All right. So that's my fingerprint. Now, there are many different types of frauds. Okay. This is one fraud, one specific fingerprint of fraud. That's all we're checking. So in a real system, you would have a number of fraudulent fingerprints. You're trying to match all these, right? And this is what they actually do in real life. Okay. I don't know if they do, the vector search or the similarity searches, but they've identified different types of fraud, and they're trying to look at all the transactions all the time to see if there's fraud. It's like a slot machine kind of thing. So, okay, so the fraudulent transaction scheme that I set up, that type of fraud, okay, I created a fingerprint. So it's generalized, okay, but there are certain characteristics, there's certain attributes, there's certain features of this fraud. Features. Boom, vector. So there's this, if you can reduce it to 2 dimensions, I see the question. So if you can reduce it to 2 dimensions, then we can plot it. So then we're looking at other sets of transactions, and we create a vector just like we do with our fraudulent, and they have their own fingerprints. And so you could say, well, okay, of all these fingerprints, which 2 are more likely to be like our fraudulent transactions? We can use the similarity search for that. If we have, really good vectors, we created all the features. Classic machine learning, right? So it would be the set of transactions in number 2, I'll say cluster, and then cluster 3. Those would be the most likely based upon the solution we have. Is the fraudulent transactions really there? Don't know yet. We might not find it. Remember, okay. What is your definite fingerprint? Okay. Here we go. This is that's going to be my definition. Okay, I'm going to show you that. It's features or characteristics or attributes of the fraud. And okay, let me go back a second here. Okay, there's a certain pattern here. Okay, we can come up with all different ways to describe this. And that's what we're going to be doing. And there's probably a ton of different ways to do that. And I just have one way of doing it. Okay, so this is how the overall system works. Okay, you just got a ton of transactions and you have a negative balance. And what's going to come out of that is a list of transactions that were considered like fraud. Okay, so I'm starting with 103 transactions. What I did is, if you think about, if you understand, text chunking for AI type rag apps, this is what I kind of did. I have all these transactions. Now, we're not going to do the number of transactions. We're going to do this by time. So we take 120 seconds. Those transactions become like one group or cluster of transactions. Now, we're going to slide 30 seconds, not another 20. We want the overlap. I don't want to get in. I'm going to run out of time if I start getting into that. So we're going to slide 30 seconds. Okay. And then we're going to get those transactions, slide another 30 seconds, get those transactions. And so when we do that, because we only have 103 transactions, we're going to end up with 15 clusters or sets of transactions. And they're not going to have the same number of transactions. We're not moving by number. It's not like move over tokens or words. We're moving over by time. Okay, so it's a little mental switch if you're kind of used to that thinking. Okay, so of those 15 clusters, there was 90 transactions in total after we deduped kind of the transactions. When I say 5 clusters, 90 transactions. Oh, we said we did our similarity search on, my fraudulent transactions. Each of those clusters has their fingerprints. We took the 5 closest. Of the 5 closest clusters, there's 90 transactions in there. Now, if you built the property graph on that, the edges right there is like 4,000 edges were built. Okay, and so we did a little graph traversals. It turned out though, the candidate paths are like 3.7 million, right? Boom. Yeah. If I didn't do the clustering in the similarity searches, it would not work on at least on the free tier. It would not. I filled up my my laptop temporary, Oracle temporary space it just doesn't work. It didn't work. So I needed to reduce the number of transactions to to load the property graph, to use that word. You don't really load it, but when you define it, the associated data is just too much to traverse. And so the clustering, like my initial hunch was like, yes, we need to reduce the transactions so we can actually actually traverse the graph in an acceptable period of time. Okay, and you might say, well, we only went down from 103 to 90. Yeah, that might not sound like a lot, but it's like millions and millions of candidate paths every time you do that. Okay, I could have made just give me the top 3 clusters, and that would even made it less. Okay, but I just said, I think I did like 80-20. I just wanted to be general. I didn't want to try and game it so it's easy to detect the fraud. Okay, then what we started to do is when I started, traversing the graph, and then I got some candidates, we actually did some like where clause stuff. We did some constraints, some rules to try and detect the fraud. And that brings us down from like a lot of candidate paths, 3.7 million, down to 132 candidate paths. Then we applied some other validations. We did some. Remember, we don't have actually even implicit foreign keys, but you know what? They probably should be within 2 seconds of each other. Otherwise, the system's got huge problems, right? So they're not going to be. We can't join on that, but there is kind of a fuzzy join. And so I just set it to 2 seconds, which is very, very wide right there. Okay. That actually, doing these final checks, there was one fraudulent path that came out, and I was like, wow. And that was the fraudulent path. And then I brought this to my buddy. I said, hey, Troy, I said, check this out. He's like, yeah, I know, Craig. That's super cool. And you cracked the nut, but we already do that. I'm like, what? You mean you don't want to like buy my solution? Kind of thing. I'm like, I did it. He's like, no, we're using a little different tech, and it's not as elegant as what you've done, but no, we already kind of do that. I'm like, shit. So anyways, okay, so let's to have a little bit of time left here. So the vector thing is obviously really important here. And that was such a great question, because what is the fingerprint made of? Okay, so these are just some feature names, right? And that's columns, features, attributes of the fraud. So if you look at all this, and I did not include the funds on, because that could have been a day or days before. And if I would have included that, I would have had to look at all the transactions when it was, when it was first funds on. And that would be, you could have a different fingerprint for that, but you're going to have a different strategy. So I only focused on what the information related to the funds off. Okay. And so this is like one of those clusters. When we did the window, each of these clusters will have, how many transactions. Remember, they can have different transactions because it's a window sliding on time. Okay. How many funds on, how many funds off. These are just different attributes, you just try all this different stuff. Some of these are probably complete crap and worthless. That's a machine learning issue. And this can be optimized, and it's not optimized. I'm sure there's other features, but each of these values, this looks more vector-like, doesn't it? Because it is a vector. And that's the vector, my fraudulent vector. So each of those clusters will be basically, these features will be extracted, and they will all have their own vector. So these are the different clusters. There's 15 in total, and each one of them has a bunch of transactions right here. Okay. And then each of those, based on the attributes of the transactions, they each have their vector. So that's their fingerprint. Now we can do a similarity search, and we get the distance right there using in SQL, SQL and Oracle. And this is the closest one right here. It only has 3 transactions. So why did it turn to be number 1? Don't know. I don't care. Okay, at this point, this is like a demo, right? It turns out our fraud is in cluster, that ranked number 3 right there. It is in there, as we'll see later. And so it was in the top 3. I grabbed the top 5 that we started building the property graph. So this is kind of classic machine learning, but it's all done in Oracle. Okay. Okay. So this is all done in PL SQL. You can download the code on this thing. I wish I had more time to do this, because if I did this with like Opus 8 or like Fable, this thing would be, it would be way better. It would be so much better, be cleaner, the code would be better, but you know. Okay, so what this page is all about, creating the property graph takes no time at all because it's DDL. It's like defining a table, you're defining a graph. Just boom, you're referencing tables and columns and stuff like that. Super quick. Traversing the graph, that's a whole nother issue, and that's a challenge. So, but get this, you know, actually traversing the graph, and here are some of the constraints that I put on this. It takes about 2 minutes, but get the, you think, well, 2 minutes, that's pretty long. I said, yeah, because it's on a free tier autonomous database with, I'm sure there's like no parallelization because I have a fraction of a fraction of a fraction of a CPU, right? And this was working off of 3.7 million, you know, paths, possible paths from only 90, you know, transactions in 5 clusters. So to actually do this on a free tier with like no parallelization, you know, fraction of a CPU, that is like, wow. I was super shocked by that. Right. So it does work on a free tier. And then when I actually built another property graph based on what came out of that, and then I applied some additional constraints, that took 2 seconds. It was super fast to actually do that. Okay. So one of the questions you might be thinking, well, why did you create 2 different property graphs? Why not just one? I could have done it in one, I'm pretty sure, but it took, when I was building this, it took so long. It didn't finish in 2 minutes. It basically didn't finish. So I'm trying to figure out how to make this thing kind of work. And once I got a good solution, I could have put those together, I think, but I didn't. So that's why it might seem like, well, why did you do this twice? Okay. Then finally, I do like a final check. I rank. I do like a balance check. Like, does this? Okay, so each of these paths is a set of transactions. Okay, this path contains 5 transactions. These contain like 4 transactions. What's the amount stolen? What's the final balance? Well, we know, right, that the final balance is 100. So all of these that have a final balance, we have a match there. The timing is within that 2 seconds, that little fuzzy timing I talked about. All of these actually matched. So the ones that matched both, the balance, got to be the balance, has to be right. The fuzzy check, I could tighten that or loosen that if I wanted to. And I wanted 5 transactions. Only one of them actually passed all these tests. And that, believe it or not, is the actual transaction, fraudulent scheme. Now, what happens if there was 2? Well, I could have tightened the fuzziness. I could have optimized, I could have done all sorts of stuff. I just got like lucky. Okay. And so this is all the information I know now. I know the serial number. I'm inferring that's the serial number. I have no database proof of that, right? And these are the associated transactions. And then here's a summary. This is the information I give to the LLM to create the 2 different emails. And boom. So there's one goes to the VP of operations, and then the other ones with all the details goes to the fraud detection group. And this is kind of what actually, something like this actually happens. So really that kind of is the demo. That's actually like that's screenshots of the real code that you're looking. I can't make that up. Yeah. So that's kind of is the demo. But if you actually want to watch a video demo, it's on like my website, it's on Vimeo, you can watch it. So where I failed, okay. Where I failed and got derailed. I didn't understand this whole disconnected thing was just like, why in the hell would you ever do this? Okay, now that I know it's legal, it's still, it was so weird to me. Even understanding how the whole industry worked, how you could represent like different companies in this elegant solution in like 3 tables with only a few columns. It took me like forever. I talked to my buddy. We were texting. He was probably like, "Come on, Craig, get this." And I finally figured it out. My original hunch was the fingerprint to reduce the complexity of the whole situation. The AI coding was just like threw me off in a different direction. I believed it. And then it wasn't working. So I went back and then things started to kind of work because of a scaling issue. Okay, was super. This is a reality right here. The LLM training data. Okay, you got to use the best coding you can get, the best coding. I mean, if you're going to do this with AI coding, I tell you, the reality is Oracle AI, SQL embedding and distance function in Oracle, property graphs, PGQL. I'm telling you, they are just not trained on that stuff. They're trained on Postgres, SQLite, all the open source stuff. But this kind of stuff, the documentation is out there, but all the blogs, the solutions, the discussions, it's just they don't know about it. Now, maybe 4.8 Opus does, maybe Fable does, I don't know. But I'm telling you, I had to keep pointing it to the documentation. It was really, really difficult. Okay. And it didn't understand the whole disconnected system thing, kind of like me. It's like, listen, you're using Oracle. Like, I'm an LLM right now. Everything I know about Oracle is relational, which means you have foreign keys all the time. So it kept trying to make and add foreign keys. It wanted the token to be the foreign key. I literally I had to copy and paste the text that said, no, tokens are useless in detecting fraud because they are randomly created and reused. And it would say, oh, Craig, yeah, I'm sorry. I'll be more careful. Did I get a refund? No, I didn't get a refund for the screw ups. Yeah. So it just relentlessly wanted to create foreign keys. And I get that. It probably does better now. I don't really know. Okay. Oh, shoot. Okay, I think that's it. Hey, thank you guys. If you got any other questions, go ahead and ask. Oh, this will lead you to the Orapub website, so you can download. I think you have to be like a free member. Yeah, because you got to get through the password thing. That'll lead you to that. And Surfer Shane, check that out. And my boot camp. Oh, together with viscosity, we can put slick eddy behind bars. I wanted the bars to move and make a noise, but I don't have the PowerPoint skills to actually do that. All right, that's it. Hey, thank you guys for having me. I really appreciate Denise and Amelie. I really appreciate you guys letting me talk about this.
Craig, thank you so much for this. This was incredible. What an interesting use case.
I know, I love it. Yeah, I do. It was just super fun. I actually gave up once because I just can't do it. It's just not working. And I went back to it and then finally got it working. Yeah, it was good.
I'm glad that you stuck with it. It was really interesting. For those of you that are still on, Craig will be at AI World. So if you'd like to meet him there, I'm sure that Craig would love to talk to you about Oracle and all the work
Yeah.
that he does.